All right, stats. We get to talk about confidence intervals for the difference between two proportions. So first off, in this section, we are estimating the true difference in proportion, P1 minus P2. That is the parameter. So let's remind ourselves, what do we know about a confidence interval? We know that it is the statistic plus or minus some margin of error. And that this margin, and that this margin of error is made up of some critical value, which is linked to our confidence level, times the standard deviation of our statistic. That is all old news. So of course, if we are trying to estimate P1 minus P2, then our statistic would be P hat 1 minus P hat 2, plus or minus. If we're looking at P, our critical value is going to be a Z critical value, Z star. And again, as we said, this is linked to your confidence level. And then standard deviation of our statistic. Well, sigma sub P hat 1 minus P hat 2, we just talked about that, was the square root of P1 times 1 minus P1 all over N1 plus P2 times 1 minus P2 all over N2. But what's going to happen here, or what do we notice or get worried about? Well, of course, if our goal is to estimate P1 and P2, we do not know it. But that's okay. We've come across this before. What do? We substitute in what we have. We're going to substitute in P hat, which means instead of the standard deviation of our statistic, we technically have the standard error, which looks exactly the same, but instead of P's, we have P hats. P hat 1 times 1 minus P hat 1 all over N1 plus P hat 2 times 1 minus P hat 2 all over N2. And again, that is technically not the standard deviation anymore. This is known as the standard error of the difference between two proportions. And this, my friends, is our confidence interval. Specifically, this is known as the 2 sample Z interval for the difference between two proportions. And this confidence interval can only happen if our conditions are met. The conditions that we know and love forever and always, random, normal, and independent. Everything stays true as to how we check these. Specifically, random, it needs random, selection, and assignment. From both populations, N1 and N2. We talked about during class that the normal condition of N times P needs to be true for both N1 and N2. And of course, if we can't check it with P because we don't know P, we're going to check it with P hat. And then our independent condition, our sample size has to be less than or equal to our population. And again, this needs to be true for both N1 and N2. So everything is the same, we just need to do it twice. Let's look at an example. Many news organizations conduct polls asking adults in the United States if they approve of the job the president is doing. How did President Obama's approval rating change from 2009 to 2010? According to a CNN poll, of 1,024 randomly selected U.S. adults in September of 2010, 50% approved of Obama's job performance. CNN poll of 1,010 randomly selected adults in 2009 showed that 53% approved of his job performance. A asks us to use the results of these polls to construct and interpret a 90% confidence interval for the change in Obama's approval rating among US adults. And then, based on your interval, is there convincing evidence that his job actually changed? As with a lot of examples, I want to take some time to look at what we have here and kind of give the information from the problem a chance to settle in our minds. So just to help things out, I am going to say A is 2010 and B is 2009. Now, we are going to do this problem in a way that is one minus the other. You can do it either way. This difference of proportions can go either way. Your answer might look different. It might be a negative version, but the idea will be the same. So that means our sample size for 2010 was 1024. NA is 1024. And our sample size for 2009, NB, is 1010. We are also told that the proportion for A, our sample proportion in 2010 is 50%, 0.5, and our sample proportion in B is 53, 0.53. This is the information we have been given. So let's do our good old confidence interval. Everything is the same as before. State. We need to tell the reader what we are doing. We would like to estimate the true proportion of the change, or maybe I'll say the true change in proportion of Obama's approval rating from 2010 to 2009 with 90% confidence, where, and now we need to define our parameters. PA is the true proportion of US adults who approved of Barack Obama in A was 2010, and the proportion of B, PB, is going to be this same thing, but in 2009. In our state, remember, we need to tell the reader what we are estimating, make sure you have true and the confidence level, and define any parameters in context. So we have a state. In our plan, we need to tell the reader what inference method we are using and check conditions. So in our plan, we will use a two-sample Z interval for the difference in proportion assuming our good old random, normal, and independent. I apologize that my handwriting is not great, but sometimes when I'm recording a video, this kind of gets a little tricky. So random. There are random samples from both populations. For normal, we have to check our n times p. So 1024 times 0.5 is 512, which is greater than or equal to 10. And because it's 50%, same thing, 1024 times 0.5, 512, that's greater than or equal to 10. And then 1010 times 0.53 is 535, which is greater than or equal to 10, and 10 times 47, 0.47 is 475, which indeed is greater than or equal to 10. Our normal condition has been checked. And for our independent condition, we need to make sure that there are, or we'll say there were, more than 10,240 adults in the US in 2010 and 10,100 in 2009. So our independent condition has been checked. So 2 sample Z interval for the difference in proportion and check all of our conditions. State plan, let's talk about the do. In the do, we're going to perform our calculations. So P hat A minus P hat B plus or minus Z star times our standard error, P hat A, 1 minus P hat A, all over NA, plus P hat B times 1 minus P hat B, all over NB. And we can do all of this in our calculators, so probably not a bad idea to do that. I'm going to pull that up right now. I am going to go to Stat, scroll over to Calculate, and we are going to use option B. Oh, sorry, scroll over to Tests. I was looking at that like, what? Stat Tests, we are going to use option B, which is the 2 proportion Z interval. And we got to plug in a lot of information. X1, N1, X2, N2. This, if you recall, P hat, oh, I can't write on here. That's okay. P hat is equal to X1 over N1. So if we are saying in our problem, this is 1 and 2. So P hat A, which really is going to be P hat 1 in our calculators, was, let's see, 50% of 1024. So the 512 over 1024, oops, ignore that, 1024. And our other was 53% of 1010, which I don't have offhand, so give me a second with my calculator. 0.53 times 1010, I'm getting 535.3. This is something we might have talked about, but not worth mentioning again. You cannot put a decimal in the numerator of these, so just round either way. If you round up or down, it's not going to change your answer too much. And our confidence level is 90%, and they want to calculate that. So I'm going to drag this in. So if we want to show our work on the AP exam, what would we have to do? We would have to tell the reader what we just did. So 2 prop Z int, where X1 was 512 and N1 was 1024. X2 was, what did we say it was already? 535. And N2 was 1010. And our confidence level is 0.90 to give us this nice little interval. Negative 0.0661 to positive 0.0067. State plan do, and last but not least, our conclude. Our conclusion. We are 90% confident that the interval from negative I'm going to change this into a percent. Negative 6.6% to positive 0.7% captures the true change in approval rating of Barack Obama between 2010 and 2009. That doesn't make sense that we get a negative percent. Yeah, all that's saying is that p hat b, or the proportion in 2009, was greater than p hat a, the proportion in 2010. So based on our approval rating, is there convincing evidence that Obama's approval, oh my goodness, based on our interval, is there convincing evidence that Obama's job approval rating has changed? Well, if it were to have changed, we would need to see an interval that was completely above or completely below 0. But our interval includes 0, meaning 0 is a possible true difference, meaning it's possible his approval rating has not changed. I think I'm going to type that. Is there convincing evidence? No. We do not have convincing evidence to suggest Barack Obama's approval rating has changed because 0 is included in our interval. Thus, 0 is a possible answer for the true difference in approval rating, meaning it is possible his job rating has not changed. That is talking about confidence intervals. Come back for the video on significance tests.